Welcome to this video on monoclonal antibodies. We're going to be looking at what monoclonal antibodies are, what their uses are, how they're made, and how they can be used to treat cancer. So you've got a brief summary up there on the screen right now. And now we're going to work through the attached relevant worksheet. So the first bit of the worksheet, we're looking at what monoclonal antibodies are. These are antibodies made from several B-cell lines or lineages. Basically, different B cells. Monoclonal antibodies, on the other hand, these are antibodies made by clones of unique B cells. Basically, a single B cell. So we need to think about what you can actually use monoclonal antibodies for. So here you've got a representation in the diagrams I've provided showing one of the uses of monoclonal antibodies. So basically, monoclonal antibodies, for the most part, tend to be monovalent. And monovalent just means that they respond to just one antigen, which gives them a high degree of specificity. Okay, so let's have a look at this example. So separating a chemical from a mixture. So if you have a mixture of different chemicals and you want to take out one of those chemicals specifically by turning it into a precipitate that can then be easily filtered out, one of the ways you could do that is by using monoclonal antibodies. So let's write a description of that. So this involves removing a specific substance from a mixture using antibodies. So one possibility could be removing pollutants, for instance, from a mixture. So it could be used to remove a pollutant or toxin from a mixture. Okay, so let's have a look at the next page and figure out if there are any other possible uses. So here you've got a home pregnancy test. Now, during pregnancy, there are certain hormones which you find in very, very small quantities in urine. You can use very specific antibodies to actually bind with those very small quantities of a substance, for instance, a hormone, in order to indicate its presence. So let's write something down for this. So antibodies can be used to identify the presence of small quantities of specific substances. For example, the hormones present during pregnancy in urine. Okay, so that's immunoassay. Another possible use is in the treatment of cancer. We're going to do a bit more on this later on in the video, but this will just be a little introduction. Cancer cells have specific antigens. Let's rub that out. Antigens on their surface. Antibodies can be used to show the presence of these, e.g. for easy removal. Another aspect of this would be immunofluorescence. So immunofluorescence is basically the use of antibodies which are bound to chemicals which will respond to things like UV light and then give off a colored light of some sort which would show their presence. So it's the use of bioluminescent molecules bound to antibodies, for example, to show or better indicate a tumor made up of cancer cells. So basically, you've probably noticed that there's a pattern to all of this. And in essence, antibodies are highly specific. They're highly specific because they will only bind to certain antigens due to complementary shapes. So let's have a look at transplant surgery, for instance. So another application of monoclonal antibodies is in treating people who have recently had a transplant. One of the problems with a transplant is that the foreign organ is going to have totally different antigens to those that you would have in the recipient. That means the recipient person will tend to basically attack those organs. Their immune cells will see those organs as foreign and will try to destroy them. So usually, people who've just had a transplant would therefore have to have immunosuppressive drugs for the rest of their lives. And that causes all sorts of other problems, including the fact that they would be open to opportunistic infections. So one way to deal with this problem is to make antibodies against the antigens on the white blood cells that are attacking that specific organ. And what you would do is, once you've made those and introduced them into the transplant recipient, you would destroy those B cells that were trying to attack the organ, and that way the organ would remain viable for longer, but you wouldn't be destroying any other B cells which would be conferring immunity, for instance, to other pathogens. So let's write something down for that. So it's the use of antibodies to destroy the specific B cells which would be attacking the recipient's or transplant organ. We had a little bit of static there. I don't know what the hell happened, but I'm sure it'll sort itself out. So steps in mass producing monoclonal antibodies. So one of the things we're going to be looking at is the idea of hybridomas. And we're going to think about what hybridomas actually are and why they're required. So if we have a look here, a hybridoma is basically a cluster of cells made by fusing myeloma cells, which are cancerous B cells, with antigen-presenting or antigen-producing cells, which would be, antibody-producing cells. So that way you can mass manufacture, in essence, the antibodies you need. So let's write something down for that. Clusters of cells made by fusing myelomas with antibody producing cells. So why do you need them? They are required to make large quantities of antibodies. So next, why must monoclonal antibodies be humanized? Using this sort of process, you're probably going to be using cells sourced from something like a mouse. The problem with that is that the antibodies from mice would be so different from the antibodies found in the humans you're trying to treat that they probably wouldn't work. So in essence, what you're trying to do is make them more similar to the antibodies you would naturally find in a human. So this makes the antibodies more like human antibodies. Thus making them more viable in the human body. Okay, so on to the next page. So here we're going to look in more depth at a more practical use of monoclonal antibodies. So in essence, we're going to talk about the different ways in which monoclonal antibodies can be used to treat cancer. So I've pretty much alluded to most of these already, but I'll just add a few more, or a little bit more detail to what I've said already. So number one, you can use them in surgery to remove tumors. So what do I mean by that? The tumors tend to look a bit like any other cluster of cells in the body. So how are you going to distinguish the tumor or the cancerous cells from the non-cancerous ones? And that's where the antibody and antigens come into play. So in essence, you would use antibodies specifically made to bind to antigens on cancer cells. These could be bound to actually, let's change that. Could be bound to bioluminescent molecules to make tumors glow. So that will make it a little bit easier for a surgeon to take out not just the tumor, but also possibly mop up some more cancerous cells that are just in the vicinity of the tumor. Another problem with treating cancer is, for instance, when you're using toxic chemicals to destroy cancer cells. And that process is called chemotherapy. So in chemotherapy, you could make this a lot more targeted so that you wouldn't end up with the horrible side effects often associated with chemotherapy. So let's write something down about that. Antibodies could be bound to toxic chemicals which then only reach toxic levels when they attach to tumors and build in concentration. Okay, so let's go on to another example. So all of this is shown quite nicely up here with various different ways in which antibodies could work on something like a cancerous cell. So if we have a look here, you can see that you can also destroy the cancerous cells by stimulating the body's own immune response. So this involves the use of antibodies to stimulate immune cells, e.g. killer cells, to destroy cancerous cells or tumors. Okay, so that's just 3 examples of the ways in which antibodies could be used to actually treat cancer. And in essence, all of these ways are a lot more targeted than older methods. So in older methods, you would end up very often with pretty horrendous side effects attached to treating the cancer. And in essence, what you were hoping for was that you would destroy the cancer before the treatment probably killed you. So that is in essence the end of the worksheet. It's often a good idea to try to do past questions on these sorts of topics, but also it is probably going to be quite helpful to redo these worksheets multiple times and to watch this video a few more times so that the information sinks in. It's always a good idea to write stuff down whilst you're revising, because you're more likely to remember it. So that is the worksheet. There'll be a link down below to a blank version of this worksheet, and then you can fill that as many times as you need to using this video and the information I've written to the side just here. Okay, so let's do a quick recap of what we've been talking about so far. So a little summary of everything we've talked about so far. So what are monoclonal antibodies? They are antibodies which are made by one cell line. Very often they're monovalent, which makes them very highly specific to a particular antigen. The reason why they're so specific is because they will have a complementary shape, or at least their binding site will be complementary in shape to the shape of a specific antigen. So that was the sort of basic introduction to what monoclonal antibodies are. Then we talked about possible uses of monoclonal antibodies. And that could be for things like immunoassay, so basically being able to identify very small quantities of a substance, say for instance with a home pregnancy test. We also talked about their use in the treatment of cancer, and also their use in separating chemicals from mixtures. And then we talked about how you would go about making monoclonal antibodies using hybridomas. And in essence, what you're doing there is you're getting cells that multiply quite rapidly to make large quantities of the antibodies that you need. So that is basically it on monoclonal antibodies. As I've already said, it's often a good idea to redo these things over and over again till the material sticks. If you found this useful, it would be quite helpful to for you to basically like this video below, and also you can subscribe to the channel so that you get notifications when new videos are added. Thanks a lot for watching the video, and I hope you come back to watch a few more in the future.